Hey, what's up guys? Ricardo here, and today we have another tutorial, this time on velocity and speed, and more specifically, calculating instantaneous and average speeds and velocities. But before we have to do that, we've got to cover a few ground-based topics. And so the first is the distinguishment between vectors and scalars. So vector quantity is a quantity that contains both a magnitude, and a direction. So that is a vector. An example of this would be velocity. Because velocity contains both the magnitude and direction of the force. And so, if we say we are moving 10 kilometers per hour east, that is velocity. On the other hand, scalars only contain the magnitude. And so, an example of a scalar quantity is speed. If I say I'm moving 10 kilometers per hour, that is the speed at which I'm moving, because I've only provided the magnitude. So, how do we calculate these different quantities? Well, velocity is equal to displacement over time, while speed is equal to distance over time. Hey Ricardo, what's the difference between displacement and distance, I hear you ask? Well, displacement is how far you've traveled from your original starting point. So if I go 10 meters north, then 5 meters south, I've only ended up 5 meters north of my original starting point, and so my displacement would be 5 meters. However, the distance traveled would be 15, because I've traveled 10 up, then 5 down, but the up and down are irrelevant, so it's 10 plus 5, and that's a total of 15. Alright, let's jump into some practice. First question we have is Andrew the ant leaves his nest and travels 5 meters west to drink some water. So let's show that 5 meters west. He then travels back to his nest, so he goes another 5 meters east, back there, takes a quick nap, as you do, and then travels an extra 5 meters east to go visit a friend. He does this in 2 minutes. What is his speed and what is his velocity over this time period? Alright, let's start with the speed. Speed is distance over time, which in this case is 5 plus 5 plus 5, which is 15, over 2 minutes. Remember, we've got to keep it in SI units, so that's seconds. So 60 seconds in 1 minute, so 2 minutes is 2 times 60 is 120. 15 over 120, if you plug it into your calculator, gives you 0.125 meters a second. So that would be Anthony's speed. What would his velocity be? Well, velocity we know is displacement over time. What is his displacement? Well, his displacement is only 5 meters east. So it's 5 meters over the same amount of time, 120 seconds. Plug that into your calculator, you get 0.0417 meters per second. But remember, it's a vector quantity, so it's got a direction, and that would be east. So if you look here, he's ended up east. Next practice problem. Charlie the cat gets scared when she sees a dog. She travels 3 meters east, takes a sharp right, presumably to dodge the dog, goes 4 meters south. She does this in a period of 2 seconds. What is her speed and what is her velocity over this time period? Alright, speed, distance over time. Distance traveled, 3 plus 4, 7. Over 2 seconds, is equal to 3.5 meters per second. Alrighty, next up, what is her velocity? Velocity is displacement over time. Now, if you know your triangles, you know that the hypotenuse here will be 5 meters. It's 3, 4, 5 triangle. So, her displacement is equal to 5 over the time taken, 2, which equals 2.5 meters per second, and the direction in this case will be the angle at which theta here falls from the horizontal line. And so in order to figure that, you can do your trigonometry if you want, but that's not the purpose of this video, so we're going to keep moving forward. Alright, average versus instantaneous velocity and speed. So what we were just doing before is the average sort of speed and velocity, which is over a specified time interval. So if you have, for example, like we had Anthony, who traveled a total of 15 meters over those 2 minutes, he wouldn't have been going at that 0.0417 meters per second east the entire time. He could have, slowed down for a little bit as he sort of went up a hill. He could have then sped up. But over the entirety of his journey, he averaged out at that sort of rate. So that's what we have the instantaneous sort of velocity and speed for. And that can tell us at exactly this precise moment what velocity or what speed was the person, cat, snail, whatever, traveling at. And so here we have two displacement time graphs. I'll just put the labels on. And so how do you calculate average and instantaneous rates of change from a displacement time graph? Well, the average rate is, so let's say they want you to figure out the average velocity from 0 to 2 seconds. Now, as you know, or maybe you don't, that the gradient on a displacement time graph is equal to the velocity. And so if you want to calculate an average rate of time change, you find where they are at the first specified point, so 0. Then you find where they are at the second specified point, so 2. You draw a straight line between them. In this case, it already is the line there. And the gradient of that will give you the average velocity. In this case, it'll be 4 over 2, which will be 2 meters per second. Now, if let's say we have an average from 0 to 4, we put the 4 there, plot it there, we draw the sort of line there, and we go, okay, that's a bit different to what's already there. And so that average would be the rise of 4 over the total amount of time, 4, so the displacement over time, which will equal 1. However, if we want to find out the instantaneous velocity, we have to draw a tangent at the exact point that they want us to calculate the velocity or speed. In a graph like this where all the lines are linear, that's not too difficult because the tangent will follow along with the line that's already there. If they say, what's the instantaneous velocity at 1 second, you draw a tangent there, well, you'll find out that it's 2 meters a second because it'll follow the same gradient as the line that's already there. When this sort of tangent method is useful is when you have curvy graphs, little funky ones like this. And so they might say, what's the instantaneous velocity here? You go, oh, draw the tangent there. And then you've got to figure out the gradient of the tangent. Let's dive into a few examples. All right, so here we have this one graph. So it's all straight lines, so we're going easy on you. And we have to calculate the average velocity between 0 and 1 seconds, 0 and 2 seconds, 0 and 3 seconds, 0 and 5 seconds. So let's just start with that. So we know that velocity is displacement over time. So velocity equals displacement over time. All right, so between 0 and 1 seconds, displacement 2 times 1. 2 over 1 is equal to 2. All right, next one, 0 to 2. Displacement over time, so at 2 seconds, they're at 2 meters. So the total displacement is 2 over 2, so it's going to equal 1 meter per second. Alrighty, 0 to 3. So total displacement of 4 over 3. 4 over 3 is 1 1/3, so 1.33 recurring. And now 0 to 5. Total displacement 0 over time 5 doesn't matter. 0 over anything will equal 0. Alright, next one. Average speed between those time intervals. The only difference here is that instead of displacement over time, it's distance over time. So between 0 and 1, displacement is 2, the distance is also 2. So the answer will be 2 over 1, which will be 2. 0 to 2, if we look at the graph, between 2 seconds, it travels a total distance of 2, it stops moving, so it's 2 over 2, it's also 1. 0 to 3, travels 2 meters there, stops there, travels an extra 2 meters, 4 over 3, same answer as before, 1.33 recurring. Now this is where it becomes a little bit different, between 0 and 5. Now, whilst the displacement will be 0, the distance most certainly isn't. So, if I travel 2 meters here, I stop for a bit, then another 2, that's a total of 4, but then I travel another 4 back down, so that's a total of 8. I travel a total of 8 meters over 5 seconds. So 8 over 5 equals 1 3/5, which is 1.246, 1.6 meters per second. Alrighty. So now for the instantaneous velocities at 1.5 seconds. Alright, so let's draw a tangent here. Oh, the tangent is flat. The gradient is 0, therefore the velocity must be 0. How about at 4 seconds? Come here, draw a tangent. Oh, luckily it's a linear graph. We can just use the line that's already there. So between 3 and 5, it drops 4 meters. So over a distance of 2, it drops 4 meters. So 4 over 2, it's 2 meters per second. But hang on a second, it's negative because it's going down. Remember, velocity is a vector quantity, so it needs the direction. So now let's do the same thing for speed. Instantaneous speed at 1.5, same deal. We draw a tangent. Nope, nothing there. 0 meters a second, it's flat. Let's do it at 4 seconds. Alright, we remember this. It equals 2 meters, negative 2 meters a second. But hang on. We don't want the negative there because that implies a direction. We only want the magnitude because it's speed. And so it's going to end up being 2 meters a second for the instantaneous speed at 4 seconds. Alrighty. We got some more practice over here. This one's looking a bit funky. What's going on? We got some sort of a periodic function drawn on here. Now, I haven't written out the questions. Should probably do that. That would help. What is the average velocity over the 4 seconds? And what is the average speed over the 4 seconds? Why don't you give that a shot? See if you've got the gist of how it all works and pause the video here. Alright, you better have paused it because we're going to go through and smash it now. Alright, so the average velocity is displacement over time. Gonna keep saying that until it gets drilled in. Displacement over time. Alright, so we start at 0, and at 4 seconds, we end up at 0. The displacement is 0. Over 4 seconds equals 0 meters per second. That makes some sense. That's pretty easy, alright? Now, average speed, which is distance over time. Now, how far did this little object travel over the 4 seconds? Well, if we look here, it went up 2 meters. It came back down 2 meters. That's 4 meters. It went back down 2 more meters. That's 6. And then it came back up 2. That's 8. So it traveled 8 meters over the 4 seconds. Which means if we do that math, which is looking very difficult, 8 divided by 4, that becomes 2 meters per second. Now, I hope you liked that sort of tutorial. And you got the gist of how to distinguish between vectors and scalars. Remember, a vector contains both a magnitude and a direction. A scalar only contains the magnitude. And then you learnt how to sort of calculate average velocities and speeds from word problems, which were the snail and the cat examples, the ant and the cat examples rather, we went over before. And then I hope you got a sense of the difference between average and instantaneous velocities and speed, and how to sort of figure them out from displacement time graphs. And I hope, if nothing else, you remember that speed equals what? Distance over time. Velocity equals what? Displacement over time. Which one's a vector? Velocity. Which one's a scalar? Speed. Awesome guys, thanks a heap for sticking with me through this tutorial. Now, let me know what you'd like to have covered next. Whether it be physics, biology, chemistry, whatever, essay writing, let me know. I'll get it done. If you got any suggestions on how to improve these videos, make them more entertaining, make them more engaging, should I include more problems, less problems, explain things clearer, explain them less clearly, I don't know, let me know. Alright guys, until next time, keep working hard and happy studying.